Hi guys, in this Grasshopper tutorial, we're gonna learn how to make the kinetic facade of RMIT Design Hub and make its facade responsive to the sun's position. First, take a look at some pictures of this project. Before working on this project, you need to have Ladybug tools installed. You can download this Grasshopper add-on from Food for Rhino. I will put the link in the caption. The focus of this channel is on kinetic facades. I've been researching this field over the past 5 years, and I plan to share my knowledge in designing, simulating, and controlling kinetic facades with you. Please subscribe to this channel and stay tuned. Okay, let's start this tutorial. Here you can see the kinetic facade of RMIT Design Hub. I try to only use Grasshopper components. These circular plates could rotate around this vertical axis in response to the sun's position. Let me hide this Grasshopper algorithm and start it from a point. Go to Geometry in the Param tab, and I need to put the point on the Grasshopper canvas. This is the Grasshopper canvas. Right-click on a point and select Set One Point. You can put it in whenever you wish on your Rhino scene. We need a line. For that, we need to have a point and a direction and a length. Go to Curve tab, Primitive, Line Style. Put it on the Grasshopper canvas, or you can double-click and write a style. Connect a point to start. Give access to direction. And here we need a number for length. I think 20 is enough. And click on this component to see that on the Rhino scene. I want to increase that to 30. Yes, it's okay. Here I want to make a vertical plane. For that, double-click on the canvas and write Extrude. Connect line to the base. Double-click, right C. Connect it to direction, and we need a number to increase the height of this plane. Double-click on canvas and write a number to create a number slider. 30, and connect it to Z. Let me connect this number slider to Z to make it parametric. Indeed, we could control the length and height of this plane with only one number slider. We need to divide it into some panels because we need to have some circular plates. So we divide it into some panels, and inside each panel we will create a circle. And following that, I will show you how to rotate them and use Ladybug tools to draw some path diagram. In order to make panels, go to Launch Box, and in Panels tab select Quad Panels. Put it on the canvas and connect the extrusion to the surface. You can change the number of plates by giving a number slider, for example 11 to U and V divisions. It's up to you. Following that, we want to make a circle inside each square. For that, we need to first extract the center of these panels. So go to Surface and put Area on the canvas. Connect panels to Geometry. Double-click on the canvas. This is another way to call the component and put it on the canvas. Connect center points to plane. Well, we have a problem here. If I'm not mistaken, we need to have these circles on the XZ plane. Yes, we need to have them in the XZ plane, but now they are in the XY plane. So we need to change the base plane. For that, you could easily go to the Vector tab, Plane, Construct Plane, and connect the center point to the origin. We have X here, and instead of Y, we should have Z. So connect Z to Y, then connect the plane to the plane. Okay, it works. To better control your algorithm, it is highly recommended to hide the previous components. Indeed, only keep the last component on. For example, here I don't need to see this component. And also this one, I need to see the panels. It's good, okay. Now we need to change the radius of these circles. We could easily double click on the canvas and write a number. For example, 12, it is too much. It's better to give another number to it. We can do that, but we want to make it parametric. And by changing, for example, this number slider, control the whole algorithm. For that, it is suggested to make a relationship between these number sliders. For example, here we have, if I'm not mistaken, 11 panels. And we know that the length of the side is 30. So we could easily divide this number by the number of panels. And now, as you can see, it's 2.727. It's not important to read the whole number. Now, we only need to divide this number into 2 to have the radius of our circles. Here we know the exact length of this side. And by dividing this number into 2, we have the radius of each circle. That could exactly place inside each panel. And here I want to use another component instead of number slider. Double click on the canvas, hold Shift and quotation, enter. Double click on the panel, enter 2 and click outside of this panel. And you have this fixed number and connect it to B. Now we have our circles, and if we change the length of line and height of this plane, we could also change the radius of our circles. I want to make some cylinders by extruding these circles. So double click and right extrude, click on this component and connect circle to base. Again, we need an axis. Here it should be Y. So double click, right Y, enter, connect it to direction. We could change the height of these cylinders by double clicking and entering a number. For example, 2.2 and connect it to the Y axis. We no longer need to see this vertical plane. We could hide it. Here I want to create a circular plate inside each cylinder. I continue my algorithm from here. Well, I want to move these circles a little inside the cylinders. So double click on the canvas and right move, select this component, connect circle to geometry. We need an axis, right Y and connect it to motion. I give a number to it. We could easily go to surface, freeform, boundary surface, and connect geometry to edge. Now we have our circular plates. Okay, we need to create our vertical axis. For that, we need to work on these circles. So you could use another component. Point on curve and connect geometry to this component. Right click on it and you can select different points. By using this component, we could select 2 points, one of them on the top of these circles and another on the bottom of them. By connecting them to each other, we could create our vertical lines. Double click on canvas and write a line and create a line by using these 2 points. Now we have our vertical axis, but we need to change them to some pipes. We could do it by going to surface and using this component. Put it on the canvas. Connect line to curve and give the radius to it. Now we have our cylinders, circular plates, and vertical axis. We can hide the rest of the components to better understand our algorithm. Here we need to use a component to rotate our circular plates around this vertical axis. So we need to put rotate 3D on the canvas. Double click and write rotate 3D. Connect surface to geometry. This component needs geometry, angle, center, and axis. Axis is C and it's good, and we need center. We need to use the center of these circles. For that, we put the area again on the canvas and connect it to geometry. And give it to the center. Okay, it works very well. We can change the angle. Double click on canvas to create a number slider. Here I want to make a number slider that starts from 0 to 19. For that, you just need to write 0.19. Connect it to angle. Remember to change the angle unit to the degree. For that, you just need to go to hold your mouse cursor on the angle. Right click and select degrees. Don't forget to hide the previous components to better understand your project. And see the changes you made by changing this number slider. Hereafter, I'm gonna use some components of Ladybug tools, but I don't intend to talk about the details of them in this tutorial. In the future tutorials, I will talk about them, and I will give you more information about each Ladybug tool's components and their functions. If you wish to go deeper into this knowledge, please subscribe to this channel and stay tuned. I have the latest version of Ladybug tools, LVT 1.4.0. First, we need to create a Sun Path diagram. For that, go to Ladybug tab 2, Visualize Data, Ladybug Sun Path. Here, location is so important. For that, go to tab 0, Ladybug Import Location. Connected to the location, we need an EPW file. You can download it or you can call an EPW file from your system. Let me call an EPW file from my system. Double-click and write path. Here select the file path and connect it to EPW file. Right-click on file path. File paths allow you to call some files from your system to Grasshopper. Select one existing file, and here I have an EPW file. Select it, and now you can see this is our sun path diagram. I want to change its scale, so double click, write 0.6 and give it to the scale. It's good, and to change the center point, go to from geometry point. Right click and again set 1 point. It's good, and connect it to the center point. This is our kinetic facade, and this is our sun path diagram. We need to define the hours of the year. As you can see here, we cannot see the sun's position on the sun path diagram. Go to Ladybug, analyze data, Ladybug, calculate hours of year. Connect hours of years to hours of years and define months, day, and hour. For months, start from 0 to 12. For that, you could double click and write 1.12. Enter. For day, double click again, 1.30. Enter. For hours, it starts from 7.18. Yes, you can see sun at 8 a.m. And I want to better see the location of the sun and the sun path diagram. So go to surface and put the sphere on the canvas and connect sun points to base. Here, I want to talk about the most significant part of this tutorial. It's about how to make this facade responsive to the sun's position. This is the final Grasshopper file of this project. You can download it from my website. I have put it there. Well, there are some different approaches to make a facade responsive to the sun's position. Indeed, there are some different strategies to control a dynamic shading system. Now, I want to talk about them. The most commonly used one is the Cutoff control strategy. In this control strategy, dynamic shading systems try to block direct sun radiations. But how we could define it in our Grasshopper algorithm? How we could use Grasshopper components to make a facade responsive to the sun position? One way is to consider the distance between the sun and our dynamic facade. But it doesn't work in an actual situation. This is because the sun is so far away from the Earth. We couldn't rely on the distance. Another way that seems to be acceptable is to consider the angle between the lines that are perpendicular to dynamic facades and the lines that connect the sun to the center of kinetic components. The angle between these two groups of lines will enable us to accurately change the position of dynamic modules. When the angle is 0, we need to keep the facade closed, and when it equals 19, we could open it. Let me explain it here and show it by drawing some lines. I want to disable Sun Path diagram. For that, this is another point that I want to give you here. Left click on your component and go out of the area of your component on the Grasshopper canvas. Right click and then click disable. Imagine this is our sun and we want to rotate these circular plates to direct sun radiations from the sun. Now we need to draw some lines perpendicular to these circular plates. And we need to connect sun to the center of these circular plates. You have actually another group of lines. Well, this is crystal clear that the angle between these two first lines is less than the second ones. And following that, the angle between two last lines is bigger than the previous ones. The angle between these groups of lines are the angle that we need to use to rotate each group of circular plates. Let's enable Sun Path diagram again. Left click on this component and go out of the area of this component. Right click on the Grasshopper canvas and click enable. Let's complete our algorithm and use some Grasshopper components to draw the lines that we have just practiced to make this facade responsive to the sun's position. I need the center point of these circles. Put a point on the canvas. There are center points. These are center points, and this is the sun's position. Double click on the canvas and write line. Here is our first group of lines, and for the second group, double click, right move. Well, we have created some points, but they are located in the inside of building here, and we need to have them in the front of facade. So go to extrusion, right click, and write minus X. Okay, it works, and now we have our points in front of the facade, and we just need to connect them to the center points to have the second group of our Now we have two groups of outlines. I want to project them on the ground, indeed XY plane. Double click on the canvas and write project. As you can see, this component project these lines on the XY plane. I hide the previous components. We need to calculate the angle between these two groups of lines for each circular plate. Double click on the canvas, right angle, you can use a line as a vector in Grasshopper. The unit of Grasshopper is radians, as you can see it here, but we need to change it to degrees. You can do that very easy. Just double click on the canvas and write degrees. Select this component and connect angle radians. And then we need to work with rotate 3D. Connect degrees to angle. All plates rotate toward the sun position. Let me change the time and see how it works. Okay, there are some points here. I have used some other Ladybug tools components and the Grasshopper file that I have shared with you on my website. You can download it. In the future, I will talk more about them. I don't want to make this video too long. For example, this component, Ladybug Legend Parameters or Ladybug Direct Sun Hours. I will talk about them in the future. I have put this algorithm on my website and you can download it. About the definition of these Ladybug tools components, you could follow my future tutorials. I will talk about them in the future. Thank you so much for your attention. Don't forget to subscribe to this channel. Stay tuned. I will talk more about Kinetic Facades. I'm Atiq and this is Kinetic Façade. Thank you.